Hey everybody, welcome back to the Pomerium live stream. Today I guess we're kind of kicking off, maybe it's a series, maybe it's just whenever, but we're gonna be trying to do these live streams, hanging out with some of the Pomerium crew, just talking about some real world stuff. And we're gonna kickstart things off today with some chatter about Kubernetes. But before we dig into that, do you all mind just introducing yourselves? I'm Nick, like I think most of you have seen me on the streams before, but Alex and Bobby, if you want to go ahead.
Sure, I'm Alex. I'm a software engineer at Pomerium. I joined last month.
And I'm Bobby, founder of Pomerium, and I wrote the original version of Pomerium. So I'm excited to talk about a lot of the things we get to interact with in our day job, a lot of the critical but lesser known edges of maintaining the type of infrastructure we often interact with.
Yeah, no, for sure. And for folks who maybe this is the first time you're hearing about Pomerium, but we're an open source, cloud agnostic, identity aware proxy. Been around since 2019 as open source project, and now it's open core. We also have obviously an enterprise version and stuff, but we love open source. So we're going to talk about Kubernetes, and me on the team, I joined in January, and I have very little Kubernetes experience. I come from more like an application developer background. Done a lot of front end, full stack. I did do Kelsey Hightower's Kubernetes the hard way recently, and I have a high level understanding of Kubernetes, but I haven't been in the trenches yet, and that's something that I'm ramping up on. But for folks maybe new to Kubernetes, or even those even aware of what Kubernetes is, Alex, do you mind just kind of giving a TLDR of what it is, or K8s as the cool kids call it?
Yeah, absolutely. I mean, I think the story really starts not with Kubernetes, but with containers. So what problems do containers solve? You're writing software. Software used to depend a lot on your hardware, the instructions your hardware is running on. Containers kind of solve that gap by packaging your software in a way that you can ship it to any kind of hardware you have. So you take this heterogeneous problem of writing code for many different operating systems or hardware, and now you only write it once, and it's like a homogeneous deployment. Now, where Kubernetes is different from containers is really you're managing a large amount of machines. You are managing how to configure your deployments at scale. So for example, you have one container, that's fine, you can ship it to other machines. But say you have 10, 20, 100 containers, how does your IT team manage to deploy these efficiently without errors? Kubernetes is kind of the engine that ties together all the management of these large cloud resources. So it's really a standardized format, and how it works is it's configuration driven. It has an API server and a control plane, which essentially act as how you deploy your containers. And people write strongly typed configurations to tell the Kubernetes API server, hey, listen, I want these containers deployed. I want these applications deployed. And it handles that kind of all magically. So you've offloaded a lot of the traditional kind of difficulties of managing a large amount of servers to like a centralized API. So that's kind of where Kubernetes comes in.
Okay, no, that's super cool. I appreciate the explainer there. I guess this is just from my own knowledge, because one of my old coworkers, John, he's done a lot of work in Kubernetes too, and he says even for smaller projects, Kubernetes can still be a great idea. I'm curious, before we kind of get into talking about health checks and stuff, like what's the tipping point where you go from Docker Compose is fine, or just just shipping it, as opposed to, okay, I should really consider Kubernetes now. Like you don't want to over engineer, but like obviously you might have an idea of the scope of your project, but I'm curious if there's like either a standard in the industry or even your own personal take on when's it a good time to flick that switch to go to Kubernetes.
So I'll probably have a weird take on this. I used to work at Rancher. We were a multi-cluster kind of orchestration framework. My experience with Docker Compose is limited. Honestly, I prefer Kubernetes. You can use K3s, K3 equally, and deploy your manifest there. Docker Swarm is great. Where it kind of starts failing is when you have multi-node support. It also kind of has limited feature sets. So it becomes complicated managing, for example, health checks. Health checks are much more simple in Docker containers, and multi-node coordination is pretty much non-existent with these health checks. I'm not super familiar with Swarm. It's kind of like a stopgap between Kubernetes and Compose, but Compose kind of starts to fail when you really want to deploy something autonomously and just have it work regardless if your computer just bricks itself. And Kubernetes is also self-healing, so that's a big draw of it.
Cool. I really got to get my Kubernetes on. I've been definitely deep in Docker Compose, and I have health checks and stuff. But to your point, I think it is a little more simplified, but doing what I need for demos right now. But I need to work on Kubernetes. So, I guess before we start talking about health checks, like Bobby, just speaking of Pomerium, like obviously we have various clients and stuff. Like, I know we have Pomerium 0, which is kind of like your just kind of self-serving offering. We have the enterprise and even core. I guess, what are your thoughts on people using Kubernetes with Pomerium? Do you find, I guess it depends on the size of the company too, but what are you seeing in terms of like K8's usage with Pomerium? I don't know if we have numbers. I don't need like specific numbers, but just kind of your feel, I guess.
Yeah, this is a hard one to answer generically, but yeah, I would say like many users of Pomerium are at least using, especially our large users and customers, are using at least some Kubernetes, especially the more recent workloads. The blessing and the curse for the maintainers is the amount of architectures we support at Pomerium. So we support, as you know, everything from bare metal, truly, VMs to Kubernetes. I would say most of the net new workloads are showing up in some form on Kubernetes for all the advantages that kind of Alex just outlined, which is it kind of lets you not have to think about not only what you're deploying, which is like what Alex said well about like containers got you, but the promise of Kubernetes is you don't have to think about the hardware that those packages are now running on. If you, and that's probably the topic of today, if you have your application be able to fit well into this orchestration system. And one of the big pieces of that is these health checks. So my non-answer is a sizable portion of our users and customers are using Kubernetes. And maybe if I were to pick off the when do you get off Docker Compose, I think Docker Compose is like super useful for like on your laptop sort of container work. But the second you do want to abstract that hardware out, use multiple machines, that coordination, you might as well just go straight to Kubernetes. As Alex said, there are other technologies like Swarm and Nomad that might get you kind of halfway there. But like for the amount of effort, you might as well just go all the way there, in my opinion.
Cool. And so like, so we've heard the term health checks a couple times here now. I guess like health checks, obviously you want to see like, is something up or like, is it finishing gracefully? What are the challenges with Kubernetes? Like I know like because I'm not from an SRE or platform engineering background, but like, I've done basic health checks, like pinging, making sure the server is up and stuff. But because I know you've been doing a lot of work with this recently, Alex, is like a lot of great work. What makes it difficult to do health checks in Kubernetes or what are the snags you've kind of run into as you've been working on this?
Yeah, absolutely. That's quite a big question. So I'll try and like decompose it a little bit.
Okay.
The first kind of challenge,
or maybe we should say what these are, right? Just like what are like these types of checks? Why are they important? Why do you care? Why is it like, what is it?
Yeah,
absolutely. So first of all, Kubernetes works on an eventually consistent pattern. So what that means is it will always try and get to the latest state despite its errors. So one thing that the eventual consistency pattern guarantees is when your orchestrator, the thing that deploys your containers and pods and schedules them to the appropriate nodes or hardware, one of the things it can use is an abstraction called health probes. And so you've got 3 types of health probes: startup, liveliness, and readiness. They all have different use cases. Startup is usually for initialization. Readiness is for serving traffic. Health is for application health. So if you hit a critical error, your pod should get killed and restarted automatically. It's kind of a self-healing process. So these health checks are kind of the life and blood of scheduling your workloads to kind of work properly.
Okay, cool. And I guess with that, like, what makes it so difficult to handle this? Like, Bobby was kind of alluding to, like, or I can't remember if you said it just a second ago or when we were talking offline the other day, but like everybody's environments are different. You know, it's not like it's like just because you're using Kubernetes doesn't mean it's like a one size fits all kind of thing. Is that part of the difficulty with these health checks, or?
Well, I'd let Alex speak to. Alex had recently done work on this for Pomerium, but every application has to like reliably be able to report on each one of these checks, whether liveliness, readiness, and startup. And maybe it's worth, Alex, you're much closer to this, going over why you would need each type of probe and why it's important, especially in the context of something like Kubernetes. Like, what does this allow Kubernetes to do? And if it's not there, like, what does it mean?
Yeah, absolutely. So kind of the trickiness I alluded to before is these health probes are interface used by Kubernetes, and it all works on eventual consistency. You don't really pull structured information from your application. Your application implements this probe interface. And how these probes works is they continuously pull at intervals, and once they hit a certain threshold, so a failure threshold, if it fails 3 times in a row, then that check has failed. If it succeeds, say, twice in a row, that check can be configured to show as successful. So, taking that mental model of eventual consistency into your application can be tricky sometimes. So when we talk about Pomerium specifically, we mentioned earlier, for those who aren't aware, it's a context-aware proxy. So really all that information it requires to route traffic is stateful. So how do you have this eventual consistency, stateless kind of check really reflect the internals of your application appropriately? It's not simple to think about conceptually, and so to implement and get it right can be tricky sometimes. So these 3 probes, the startup probe is for syncing up your container. So it's for starting up the container. Your container won't start successfully until that startup probe succeeds. It's typically a long probe. Most applications don't implement this, but stateful applications typically require this because a lot of setup takes time, and you want to make sure your application is set up before it serves any traffic. The startup probe takes priority over all the other probes. The readiness and liveness probes are basically health checks. Where they differ is readiness is serving traffic, so your application is ready to serve traffic, and the liveliness probe checks the health of your pod or container. And what's really crucial there is the liveliness probe will kill your pod. So it'll kill your application if it fails to meet that success threshold or failure threshold. So it can be difficult, right? Because there's situations where you want your readiness probe to be online, and maybe situations where your health probe wants to be offline, and vice versa. Your readiness probe, you may be not good to serve traffic, but your application is doing fine internally. So it can be really tricky to think about these things.
Yeah, and I'm probably gonna say the obvious here, but like the fact that like if something's not started properly, we might start routing traffic to it, and this is what we've seen happen. This is why we're adding these health checks, just to improve things. But because people might not know, like, hey, I just went to this route and nothing's happening, and having these health checks are obviously, it's gonna just make this a lot more robust.
Yeah, I think like a key thing here is like, and Alex was alluding to this, is like it tells Kubernetes or these systems when it's okay. Like primarily, it does a lot of other stuff, serve traffic, and in that particular, in our case, Pomerium is ready to serve traffic. So like, to break it down, you can flip the on switch, but like when do you know that Pomerium actually has all that context we use to make policy decisions? Maybe the proxying capability might come on like right away. Like we could technically serve traffic, set up like a socket. We could route traffic from point A to point B, which is one thing. But the important thing for Kubernetes is like, does this particular node have your group memberships, our policy information, all that context to appropriately serve traffic in the way in the context of what Pomerium does. And so that gets into like the difference between like readiness, and I'm probably going to screw this up because I always confuse liveliness and I think start it up. So Alex, I'd be curious on that, but that's a big separation, which is like, okay, now this pod is ready to actually serve traffic and have Pomerium do its job, as opposed to have just been switched on, and you might all of a sudden have traffic going to a pod that isn't actually ready for that traffic.
Yeah.
Yeah, absolutely. And like one of the real usefulness of these checks is it'll deschedule that pod when you hit that unhealthy state. When it's no longer ready, that pod is basically invisible, and it's pretty loud when it fails. So operators of Kubernetes will tell, this pod is not working. And this can be especially useful if you roll out a new version and this new version isn't, binding to, say, ports for some reason, or if it's scheduled on a node and that node has issues and it can no longer schedule on that node, it'll start up, but it won't start serving traffic. It won't signal to applications trying to use it that it is healthy. It will basically be invisible until it's ready. It's really a powerful system, and it integrates with a lot of components in Kubernetes. I'm happy to talk more about that, but probably for now.
Cool. I guess I have one question. Like, obviously, this helps with avoiding downtime. I guess I can't remember if one of you mentioned it just in Slack or just chatting in one of our demo days, but this also helps with upgrades, right? Like, because obviously you want older versions of things coming down gracefully and not serving newer traffic. That is something that it handles as well?
Yeah, absolutely. Kubernetes has this whole rollout mechanism for its workloads. The checks are essential to that rollout process. If you don't have health checks, your rollout process will basically happen instantaneously as soon as the container processes are ready, which may not be what you want. When you have these checks enabled, that rollout waits for these checks to come up, and you basically can configure how many of these workloads should go down while the others come up. So you really have this kind of automated, like IT kind of like, you don't even need to think about it. And if there is an issue, it's so loud you can't miss it.
Okay. So obviously big win for observability there too.
I mean, I guess I have a question for Alex as you were thinking about implementing this for Pomerium, which was like, I feel like there's a notion of, okay, the problem of how do we know that Pomerium is ready to serve this traffic? It's okay or not okay. Did you like mentally go through the architecture and think about what are the hard dependencies to say, yes, it's ready? And then were there any surprising things that felt like soft dependencies for, hey, it's like in a degraded state, or we could still serve? Like, how did you think about like, or all, because of what we do on the security is pretty much everything we have a hard dependency for readiness?
Absolutely. So I started with kind of thinking of Pomerium as, well, I like to call it macro service versus microservice. You can run Pomerium in split mode, and you can run it in all-in-one, and all-in-one is the recommended method. But essentially under the hood is it's spawning multiple services that serve different types of workloads and APIs. So kind of the mental model was I went with a service lifecycle kind of idea, which is an abstraction that Google's used very successfully with its Guava library. And also a lot of new cloud native applications are using that in Go, such as Cortex. I think Pyroscope is also using this, but this kind of way of thinking of services as a lifecycle really facilitates these health checks. And basically this lifecycle works as created, starting, running, and terminating. And so when I applied this to Pomerium, not all of these lifecycles were relevant, but essentially the starting check is kind of this gate where you say, we need these things to complete successfully before we start these services. And once you've done that, then you can move on to the other checks, which is like, is my backend, like my data storage healthy? Oh, is my IDP kind of having issues? Is my cache expiring? All these things factor into the more dynamic probes, and that's kind of the ready state. And the way I thought about it was I re-implemented kind of the eventual consistency pattern was once you report a state, you should be in that state until basically something goes wrong. So when you're running and you hit an error, you're in an error state, but you never move to that terminating state unless you're shutting down your application. These kind of lifecycle moves are atomic. Once you transition from one state to another, you can't really go anywhere from there. And these errors are kind of like eventual consistency. You report them as they come up and as they arise, and it really helps with kind of, developing a good model of testability, stability, and kind of testing your assumptions as you work through it. And for Pomerium specifically, you've got authentication, authorization, records, proxying, Envoy. You've got all these things to think about. And so really I went about it in like a piecemeal type fashion. Like, okay, how do I check that this is up and running? And I went one by one. And there's also some edge cases where we deploy in various different deployments. So we have our enterprise offerings, which require different health checks. And we have Ingress Controller, which runs in Kubernetes, which has its separate health checks. And so you can get into some really advanced patterns. For example, when we run in split mode, we need to have a concept of pod readiness gates, which is where something external to your Pomerium core is telling you, hey, we're not ready to serve traffic yet. Just wait a minute until we resolve the issue. So it does get very, very kind of less obvious than you might think as you go on.
Totally.
Okay.
I think this is why it's, Pomerium's been around for a while, but like this is still something like that we're trying to improve because we have so much state, we're deployed in so many different ways. Like, are you ready? Or like, are you alive? It turns out to be a much more challenging problem to sort through than it might seem at first blush.
Yeah, and if you think of like a particular edge case, like caches expiring that are holding your kind of cached identity, your sessions about your connections, that's not obvious. Like I still am working on solving this problem in the right way, because as long as your caches are there, you can serve traffic. But if they're not there, are you really unhealthy? Or is there just no sessions? How do you know? What's the difference? So it's not obvious to reason through these things. And I'm sure it'll require continuous improvements and continuous work as we figure out more how the system should work properly.
100%.
Yeah. No, I guess that's true. You could still have cache and you could be in a bad state as well. So
absolutely, yeah.
Yeah. Okay. And you definitely don't want to be in that serving cache and like, yeah, everything's fine. Oh, 2 hours later, oh no, nothing is actually running. Okay. So it can be pretty complex, but it's nice you're sticking to the patterns, like the eventual consistency pattern. And I forget what the other pattern you were mentioning that Google uses as well. But and these are like obviously we're implementing this at Pomerium right now, but this is kind of common in the K8 space, I imagine. But like, I guess just like you're discussing, like somebody who might be working over at Google might obviously have to handle health checks differently. Obviously, it's not a one size fit all, like you were saying.
It's completely application dependent. And that's kind of the hard part is, when non-obvious problems arise, you should do your best to surface this, especially when you're talking about a self-hosted product, which Pomerium is. You want to give the best tools available to your customers to tell them what's going on.
Mm-hmm. Yeah, I mean, one I can immediately think of is like it's hard within Pomerium ourselves as we think about all the ways we can serve traffic, we're deployed, all those things you mentioned. But I feel like some of this even bubbles up to like an organizational decision level, right? And so like cache invalidation is like, can't get away from it no matter what you work on in computer science is a problem. But I think something I often think about is being organization specific, which is, say we're caching, say, group membership to make policy enforcement decisions for some amount of time. Different organizations might have different perspectives about, say, closing open or filling open or failing close, right? Say the group membership is, misses on an update and is, 10 minutes potentially stale. Is that something that should trigger a readiness, check or not? Like some organizations we work with would say absolutely not. And many would be like, I'm not changing Active Directory that often that this is a concern. So I'm curious how you thought about that when you were approaching this problem, because this is the stuff that I think about, more on the policy enforcement side, on the security side, that's really tricky to get right. And it's really hard to give a one size fits all answer to. And in the case of like, do we literally not serve traffic to this pod because of this, cache invalidation is tricky. I'm curious how you thought about this when you were working on this feature.
Absolutely. That is one of the hardest aspects, especially for a product as mature as Pomerium, where we have so many features really, and so many different ways to deploy it. having a catch-all kind of mechanism may not work for everyone. So the way I was thinking of doing it was configuration driven. So essentially, you've got your required checks that are loaded internally by Pomerium based on what services you're running. But you can configure. So let me step back for a moment. These probes are configurable via the Kubernetes deployment interface. And so you can set higher thresholds, higher timeouts, higher retries. That approach is also limited. It's less granular. If you have issues with syncing your internal services, is your readiness probe false or true? You may be serving a lot of traffic through that instance. It may be okay to make this one particular proxy route fail, and not fail all the others. Like that could cause like cascading failures. So one of the ideas I played around with was, user filtering of these basic statuses. I mean, each status is attached to an internal service running. And so that would be configurable by users. Say, hey, in this readiness check, maybe I don't want the authorization, or maybe you do. Actually, you probably want the authorization service, but you want the authentication, maybe notifications, kind of like not part of your readiness check, but maybe part of your health check. And so by default, they're all enabled, but you have that kind of option to filter through these. And so that's a tricky part of like the UX is like, how much do you want to configure and how much do you want to let users be able to kind of work around maybe some particular deployments they have? It's an open-ended question, really.
Yeah. Go ahead, Bobby.
Well, I just had more questions because this is a tricky one. Like, how did you think about, like, totally agree with the approach of configuration and like depending on giving a lot of empowerment to our end users. But how do you think about like sane defaults here and like in the balancing of that and like, Yeah, I mean, the same defaults, especially as a security first company, is all of them. If it's running, check it. That may not work for everyone, particularly because there's so many different environments, but really the same default is check everything. If it's running, just check it. As from the UX, it just comes from working with distributed systems. I'll take the example of Cortex Metrics, which runs like 5 to 7 services. Its microservices are communicating, but their readiness checks are really not that great. You're waiting for one thing to become ready. And you can poke in their UI and you can see the microservice status. And when you talk about, leader election, which you kind of mentioned before, like group membership, leasing, that problem becomes infinitely more complex. So like how much do you want to allow to go through before you enter the ready state or show as unready? So my thinking was, I wish I had these things in distributed systems. And I'm sure some services do kind of implement that. I think Envoy has its own notion of like internal health checks that it services via its ready probe. So my thinking was along those lines is what would I wish I had when I was operating these like large scale systems?
Cool. And you were talking about the UX of these health checks. So like there's config, people can tweak certain things. Because I haven't really been deep in this stuff, obviously, but like if my company was like, yeah, this health check is good, but I need to extend something, are these health checks, are they leveraging the open close principle where people can wire up additional stuff without breaking things? Or is that really just config that we open up to them?
I think that would be tricky to implement properly. Again, like the health checks are reported in an internal state. So opening that up to users to configure, extend is probably not a good idea in terms of a security concern, but also in terms of implementations. It doesn't serve a use case as we should be the ones trying to give you the best possible experience. It's also difficult because, there's so many different ways you can think about these health checks. And if you did want to propose kind of extensible health checks, I think you would do it through Kubernetes mechanisms that exist already, for example. You would take a well-defined extension mechanism like CRDs or readiness gates and configure those via your Kubernetes controller, your ingress controller. So how you would surface those extensions needs to be thought about like kind of carefully. But that's definitely something we could do down the line if there's demand for it.
Okay. Yeah, so I guess another plus for Kubernetes being very extensible. And I guess if they had additional health checks, they would just add those themselves, like their own bespoke ones alongside ours. Like we'd always want ours to be there, obviously, to your point of if it's running, we want to check those things. But
yeah, well, the thinking is you really, these health checks are pretty bare bones to the working of the application. But if you've got something more complex, you need to look at your observability signals, your logs, your metrics, your traces. And we provided excellent visibility into a lot of our product already. And so that's where I would go look first instead of trying to extend health checks for Kubernetes.
Yeah, and in terms of observability, I'll just give a shout out to in our 30 release, we were on I forget the name of it. It was 2 projects. It's now been merged as like it's just OTel. So we have OTel traces. I'll drop a link to that. But yeah, we got all kinds of observability goodness. I mean, we had observability before, obviously, but just moving to OTel was a good move. So.
I would love to hear Bobby's thoughts on potentially extending health checks and what that would look like in Pomerium.
Yeah. Across what factor? I mean, I think I'd ask more what you have in mind with the question.
I mean, for example, you want to tie in some additional checks into your health probes, or those basic health probes. You find something in your particular environment that you want to check with respect to Pomerium.
Oh man, I would love to do a lot here. I mean, I think a challenge we have at times is we are the gateway, right? And so very often any proxy sort of has this problem, or load balancer, which is often when things go wrong, what end users or operators see first is Pomerium or some screen of Pomerium. And I would really love to give, I mean, this maybe not exactly what you're asking, but more clarity around what is failing, because it's often not Pomerium, but it looks like Pomerium. So the optics around what we do sometimes can be challenging. And I often think of Cloudflare. Cloudflare does this quite a bit. In their role as showing this graphic of like, it's not Cloudflare that's down, I promise. It's the thing upstream to us. And so I don't know if this is exactly what you were asking, Alex, but I would love to give a lot more telemetry and insights, not only to Pomerium, which I think we could do, just like instrumenting each of the things that we touch, but the caches, especially around authorizations, like how quickly these things, like I think we could always do more there. But I think the real pain point, we see on the ground is like, is often it's not Pomerium that's having issues. And I would like to use our position in the stack to help more readily surface what's going on upstream of us. So I don't know if that was quite what you're asking, but that's a challenge for us.
Is it cue the DNS joke, I guess, at this point? Is it DNS?
It could be. It's just a lot. Pomerium interacts with a lot of infrastructure primitives that are difficult to reason about. And DNS was a week for us. Unfortunately, we can't talk about it quite yet. Yeah, but we'll probably have an announcement next week on maybe as a follow-up is to this to make it a series. We can talk about some challenges we had with DNS that didn't have anything to do with us directly, but yeah, maybe that's a call for next week's segment.
Yeah, for sure. Yeah, no, that's cool. We're almost at time here, but I guess before we wrap up, this is great. I love having these informal conversations about like just real world stuff, and I love. I'm pretty sure, is your PR in the open source in the open core? I think I dropped a link to it in the private chat there. Is that the one? Just in case people are curious. I mean, I love that we work in open source, so I always like to share whatever we have. So.
Yeah, absolutely. That's the one.
Okay.
Lots of work in progress stuff behind the scenes going on that PR. So look for more updates on that.
I'd love to ask if people are doing similar sort of health checks or discovery for their app, where would you point them as good resources? Because I feel like that's always a challenging thing. Where would you go?
Well, I would go to your local subject matter expert first, but the second place I would go would be the Kubernetes docs themselves. Those are pretty fantastic. The second thing you can do is poke through open source projects. That's the second fastest way after looking through the official docs of implementing these health checks. And once you've done both those things, it's getting down in the weeds. You got to try it out yourself. You got to verify what's being said at the end of the day. So that's always kind of the challenge.
Yeah, still got to put in the work. Yeah. Cool. Well, I think that's a good place to wrap things up. Thanks, Bobby and Alex, for hanging today. I really appreciate you taking the time. I know we've got a lot on the go at Pomerium, but it's a lot of fun, and I'm looking forward to doing more of these in the future. If folks enjoyed this, just don't forget to give a subscribe to the YouTube channel. We're just at Pomerium_IO. And yeah, we'll see you in the next one. And thanks everybody for hanging. And Bobby and Alex, if you don't mind just hanging on.